Good morning, everyone. Glad to have you with me on this Wednesday. Notice in the pinned comments where it says that we're on week 5, day 1, page 2 of the package. Okay, we are skipping week 4, day 4. We're moving on to week 5, day 1. It is page 2 in the package. I need everyone right now for the first 2 or 3 minutes to find this here on your package, please. We're in week 5, day 1, page 2. Week 5, day 1, page 2. Good morning, Elizabeth, Miss Felice. Good morning. Tater Top, good morning. Alasia, glad to have you with us finally. You know, you done took 2 or 3 weeks off. See my boy Samuel, good morning. Darian. Aaliyah, good morning. Once again, we're on week 5, day 1, page 2 in your package, okay? Week 5, day 1. Week 5, day 1 in your package. Give me 1 second, please. 1 second. Good morning, Miss Blyther, Miss Wallace. Good morning, Genesis. All right, here we go. Let's get started. All right. Just to let you guys know, week 4 and week 5 in the packages are very similar. So there's a possibility next week that we're going to skip on to probably week 5, day 3 or week 5, day 4 for Monday. I will be letting you guys know because it's all pretty much the same type of work. And I feel that the majority of, first of all, I just want to say thank you to everyone who's sending me the DMs with their work. I'm very proud of y'all. Second of all, the work appears to be a little easy. So that is why I'm saying that on Monday, when we come back to meet, we're probably going to be on week 5, day 3, or day 4. So we can move on to something else, because this work here appears to be pretty easy to you guys, which is a good thing though. Okay. Now, here I just wanted you guys to take the time to read the objective, or I will read out loud to you. And it says, by the end of today's learning, I will calculate probabilities of events for chance experiments that do not have equally likely outcomes. Okay? Once again, by the end of today's learning, I will calculate probabilities of events for chance experiments that do not have equally likely outcome. Okay? So, here's just a teaser, a brain teaser for you. It says, Kyrie glances at his phone to check the time throughout the day for 24 hours. What is the probability that he will see all the digits reading the same? For an example, at 4:44 p.m. or it could be 4:44 a.m. All right, during any single glance. The watch is set up to a 12-hour U.S. format, not a 24-hour European military format. Okay, so just think about the time that we use on the daily now, right? You have from 1 a.m. to 12 a.m. Then you have from 12 a.m. to 12 p.m. That is our 24-hour span. Okay? So I want you in the comment section. Okay, I'm going to give you guys probably like 2 or 3 minutes to think about what they're asking you. They already gave you one example of 4:44. It can be 4:44 p.m. or it can be 4:44 a.m. All right? What is the probability that he will see all the digits reading the same? Samuel and Elizabeth, pay attention, please. Stay focused. Or instead of worrying about the probability in the comment section, right? I want you to give me some times. How about that? Give me a time that we can see when all of the numbers are the same. Okay? They already gave you one example of 4:44. Okay? So I also want you to add on AM or PM, so I know exactly which time you are referring to. Good morning, Mr. White. Glad to have you with us, sir. So right now in the comment section, I'm asking you guys to put in there, give me a time where all the numbers are the same. All right. So Tater Tot said 11:11 a.m. That's good. Dion's Reaper said 7:77 a.m. is not a time. It has to be a time. Okay. 5:55 a.m. by Demaya. That's correct. Sweetie Boy said 12:12. That's not correct, sir. It can only be one number. Has to be the one same number. Speedy Boy, you got 12:12. You have 2 different numbers. Okay. 3:33 a.m. King Ant. That's correct. Good morning, Sean. Miss Blyther said 4:44 a.m., which she stole from the example they gave us, but it's okay. Someone said 1:11 p.m. That's correct. Good morning, Joe. Ms. Blyther said 2:22 a.m. Demaya, you can't use 6:66. That's not a time, ma'am. Lizbeth, that's not a time. It has to be a time. Naya said 1:11 p.m. 3:33 a.m. Okay. So remember, it says that he will see all the digits reading the same. Some of you are giving me different numbers, okay? It has to be one number across. Good job, Demaya, Elizabeth, King, and you can't use 1010 because that's a 1 and a 0. Miss Blythe said 1:11 a.m. Okay, it can only be the same digit across. So if you think about it, correct, the highest you can go is using a 5 because there's no time that says 6 hours and 66 minutes. That's not possible. Okay? And then you can go up, so you can use from 1 through 5. And then you can use 11. That's it. You can't use 6. You can't use 7. You can't use 8. You can't use 9. You can't use 10. And you can't use 12. But you can use 11. Because you can say 11:11 a.m. or 11:11 p.m. Alright? So good job on the participation piece. Okay? That is what we're working on today. Something very similar. Alright? So we're going to go on down to the next page. Page 3. Okay? Page 3 said, last week you learned how to find the probability of an event when the outcomes in a sample space are equally likely. You divide the number of outcomes in the event by the number of outcomes in the sample space. What if you have a situation where the outcome in the sample space are not equally likely? Example number 1. It says Charlie is training for a race and is supposed to run every day during the week. The table below shows the estimated probabilities of running 1, 2, 3, 4, 5, 6, or 7 days a week. Okay, so let's look at the table right quick to make sure we understand. This right here is my number of days representing my top. The bottom is the probability. Okay, so day 1, he got 0.1. Day 2, he got 0.1. Day 3, he got 0.1. Day 4, he got 0.2. Day 5, he got 0.3. Day 6, he got 0.2. Day 7, he got 0. All right. So, if you look below that, it says, I want you to find the probability that Charlie will. In order to find the probability of an event, I added the probability of each of the desired outcomes together. Okay, now, not quite sure we have really spoken about the word outcome, but in this particular situation, the number of days, and I want you to write beside here, number of days, I want you to write income. Next to probability, I want you to write outcome. Okay, this is my income, this is my outcome. So when it says in order to find the probability of an event, I added the probability of each of the desired outcomes. These are my outcomes here. Those are my outcomes. All right. So let's look at A. Run more than 4 days during the week. Okay. So if I need to add the probability of the desired outcomes, it said run more than 4 days a week, right? More than 4 days. So if you look here, that's how they came up with 0.3, okay? Because 4 days, you got 0.2. 5 days, you got 0.3. 6 days, you got 0.2. 7 days, you got a 0. That is where those digits come from, okay? Now, let's make sure that it can be a little confusing because you have 0.2 that was presented twice, but as you see here, they only have it once, okay? That is because for the 4th day and the 6th day, it is still 0.2. So the outcome are the same, it's just for different days. So you don't need to add it up multiple times. All right? So as you can see here, when they added those up, they got 0.5. So the probability that Charlie will run more than 4 days a week is 0.5. So I know this can be a lot. Well, it may not be a lot, but it can be a little confusing. Okay, so I just want you guys to look at that for about 30 seconds to a minute before we move forward. And let's see if you guys have any questions or any misunderstandings. Good morning, Lionel, Miss Proctor. Glad to have you guys with us. So can I get a thumbs up, please, in this section before I move forward to make sure we guys understanding what they're asking you to do here in order to define the desired outcome? DeMarcus said he with me. Randy said he with me. King Ant is with me. Leak Retard. Lisbeth. Big Daddy Green. Snaya. Miss Blyther. Simba King. Jalen. Demaya. Genesis. Okay, cool. So let's look at number. Let's go down to letter B, right? I'm sorry. Give me a second. All right, let's look at letter B. Letter B said run at most 3 days. Okay? At most 3 days, right? That means no more than 3. So if you go back up and look at the chart, right? If it ran 1 day, the outcome is going to be 0.1. If they ran 2 days, the outcome is 0.1. If they ran 3 days, the outcome is 0.1. Okay? So for all 3 of those days, I just added all 3 up for each day. So the probability that Charlie will run at most 3 days is 0.3. That is the probability. Good morning, Miss Rucker. Just to make sure you guys, well, let me ask you this question here. If the probability is going to be 0.3, in the comment section, please tell me, what would you do if I said I want to know the percentage? If we know the probability is 0.3, what would be the percentages of running at least 3 days, running at most 3 days? What would my percentage be? If the probability is 0.3, what would my percentage be? Tell me give me the answer and tell me how you would get the answer, please. In the comment section. Lisbeth, how would you get that? How did you guys get that answer? That is what I want to know. Elizabeth said she would move the decimal places in the right. Convert it to a percent is what Darian said. So the majority of all of y'all answers are about 90% correct. I know you guys, I see what you guys are trying to say, but what I was looking exactly is for someone that said to move the decimal 2 places to the right. Okay, some of you guys are just saying move. Oh, okay, so they misspelled it. Okay, because all you need to do is convert the fraction into a percent. Move the decimal 2 spaces to the right and get 3. Okay. Rising Phoenix said it's 3, so that's 3.0. So, hold on. So, DeMarcus, it's not 3.0, it's 0.3 initially. So, remember, when you got a decimal and you got to convert it to a percent, it's going to be 0.3 converted to 30%. Okay? 2 spaces to the right. So good job. So because we're not in person with each other, when you guys are giving me answers in the comment section, which I really appreciate, I just need you to be more direct and more clear. Okay. Remember, this is not a competition or a comparison. It doesn't matter who put in the comment section first or not. Okay. I just want you to make sure you are being direct and clear with it. Good job, DeMarcus. Elizabeth, good job for correcting yourself. All right. Please make sure that you are watching your spelling and your words, okay? Are there any questions? All right. Go over to page 4. Move on down to page 4. Move down to page 4, right here. Example number 2. Example number 2. All right. It says Sarah surveyed her friends to determine the number of pets each friend has. The survey results are shown in the table below. Number of pets, number of friends. Okay. Here we go. So she has 6 friends that have 1 pet. She has 3 friends that have 2 pets. She has 1 friend that has 3 pets. Then she have 2 friends that have 4 pets. How many friends did Sarah survey? How many did she survey? So they already gave you an example. You're adding them up. 8 plus 6, which is 14. Plus 3 is 17. Plus 1 is 18. Plus 2 would be 20. All right? It would be 20. Now, part B. Part B says, what is the probability that a randomly selected friend does not have any pets? Write your answer as a fraction in lowest terms. Okay? So, although they have the answer there to you guys, right? I just want to make sure you guys understand how. The question said, what is the probability that a random selected friend does not have any pets? Does not. She have 8 friends that does not have any pets. So remember last week I told you your denominator is represented by the total. Okay? The total. There's a total of 20 friends. So my denominator is 20. Okay? Now, how many friends does not have any pets? She has 8 friends, does not have any. That's why she put the 8 there. Okay? Now notice they did not give me an answer as 8 over 20 because what did they do to this fraction here? They reduced it or simplified it to 2 over 5. Okay? They reduced it and simplified it. So if you look here, the 8 represents the number of friends who have 0 pets, and 20 represents the total number of friends surveyed. The probability that Sarah was selected friend who does not have any pets is 2 over 5. 2 over 5. Now, let's see, just to go a step further. 2 over 5 is a fraction, but can anyone in the comment section tell me what is 2 over 5 as a percent? What is 2 over 5 as a percent? Ms. Blyther said 25. Speedy Boy said 40. Elite Retort said 40. Simba King said 25. Lizbeth said 40. Who that is? DeMarcus said 40. I don't know who correct. I don't know. I don't know. Aaliyah, Genesis. So remember, a quick way to convert a fraction into a percent is just simply multiplying it by 100 over 1. So 2 over 5 times 100 over 1 will give me 200 over 5. 200 divided by 5 will give me 40%. 40%. That is a quick way to convert a fraction into a percent. Okay? Or I know some of you possibly convert it to a decimal first by saying 5 into 2. Remember, when you got to convert your fraction to a decimal, then I can say that 5 goes into 2, which 5 cannot because it's too big. So therefore, I add a decimal and a 0. Okay? So then 5 goes into 24 times. 4 times 5 is 20. That gave me 0. So now I got a decimal of 0.4. And we know that when you convert a decimal to a percent, right? Then I'm going to move my decimal 1, 2. And that is how I would come up with 40%. Miss Blythe, I still love you. It's okay. It's okay, girl. I don't want to fight you. You just was rushing. That was it. That's why you got her. I know you know what you're doing. Just stop rushing, okay? Just stop rushing. Moving on. Moving on. So here, what they did was on page 5. On page 5. Get my paper here. It said the table below shows the possible number of pets and probability of each number of pets. Complete the table by writing probabilities as a fraction in lowest terms. Okay? In lowest terms. So they already did the first 3 or 4 for you. 8 over 20 gives 2 over 5. 6 over 20 reduces to 3 over 10. This here was just 3 over 20. It cannot be reduced any. This here was just 1 over 20. It cannot be reduced any. Now, how many friends were there that had got 4 pets? How many friends were there that had a number of 4 pets? First of all, that is what's going to represent your numerator. Okay? That is what's going to represent your numerator. So now, I need you to tell me what is that number? How many numbers represent how many friends were there that had 4 pets? 2. Good job, Demaya. So now our numerator is going to be 2. So if the numerator is 2 and the denominator is 20, right? What is my final answer going to be? So yes, we agree the answer is 2. That's correct. All right. We agree. There was a total of 2 friends that had 4 number of pets. Correct. So now, what is my answer going to be? What will go here into this blank box to represent the probability? What is my fraction going to be? Good job, Jalen, Darian, Naya, Leak Retard. The answer would be 1 over 10. King Ant, you got to remember, 2 over 20, it has to be reduced. Good job, Lionel. Mr. Carter, good job, DeMarcus. It has to be reduced, okay? If you submit 2 over 20, it's going to be incorrect. Remember, all fractions must be simplified. Good job, Ms. Blyther. So you didn't rush this time. You got it correct. Good job. Good job, everyone. Any questions? Let me get can I get a thumbs up or a thumbs down in the comment section before we move forward, please? Okay, looking good, looking good. I understand how you got 2 over 20. You have to simplify. Okay. Thank you for that understanding, Ms. Blyther. I appreciate that. When you simplify 2 over 20, it becomes 1 over 10. Both of those numbers can be divided by 2. Good job, good job. So I got a lot of thumbs up, which means we can move on. All right, cool. Let's move on. Page 6. Now, you see this right here on page 6? It says what? Your turn. It says your turn. Okay? So, this is what this reads. When Sasha goes grocery shopping, she does not always buy the same number of bananas every time. The number of bananas she might buy and their probabilities are shown in the table below. So, probability, the number of bananas the number of times she buys 0 bananas, probability 0.1. So there's your number of bananas. There's your probability. You're going to use this table here, okay? You're going to use that table to answer letters A through E. Letters A through E. Notice that the sum of probabilities in the table is 1 whole. Okay? This is always true. When we're adding up the probabilities of all possible outcomes, the result is always 1. To find the probability of something not happening, you can take 1 and subtract the probability of the event. Okay? So, what I want you guys to do is they're going to give you probably about, 3 to 5 minutes to answer these here questions. What is the probability? A says, what is the probability that Jenna buys exactly 3 bananas? What is the probability? So I don't need you to put it in the comment section. Do not put your answers in the comment section. I just want you to fill this out on your paper. If you don't have the paper, then write it on scratch paper if you don't have the package. Okay? Trying to make it a little bigger for you guys. There we go. I guess that's too big, huh? Fraction, Elizabeth. You can turn it into a fraction. Or you can just keep it as the decimal that it is. Okay. Now, let's bring it back. Where is the page? Okay. All right. Now, for those of you who just joined, I see some people that just joined, know that we're on week 5, day 1, but we're on page 6. Okay? Week 5, day 1, page 6. All right? What time? Okay, 10:36. Anybody else need any more time? All right, cool. Here we go. Here we go. Nah, got it. I'm done. Okay. All right, so can anyone in the comment section tell me, A, what is the probability that Jenna buys exactly? You need to underline the word exactly, okay? Exactly 3 bananas. Okay? What is the probability that Jenna buys exactly 3 bananas? Okay. All right. See DeMarcus and Darian and Elizabeth. I think that's Marquette. King Ant. Okay. That is correct for A. 20%, or you could have just said 0.2 as a decimal. It does not matter. All right, B. What is the probability that Jenna does not buy any bananas? Any bananas. Part B. What is the probability that Jenna does not buy any bananas? Good job, Genesis, DeMarcus, Randy, Darrow. 0.1. Tater top. The answer will be 0.1, or you can say 10%. Okay? Now, let's look at letter C. Let's look at letter C. What is the probability that Jenna buys more than 3 bananas? More than 3 bananas. What is the probability that Jenna buys more than 3 bananas? So, a lot of you are saying 0.5 or 50%. That is correct. Because you got to look here. It says more than. So, you cannot count the 3. You got to start with 4 and 5. And for 4, that's 0.2. For 5, that's 0.3. Remember what we just did about 5 or 10 minutes ago? You add up all the probabilities that it's referring to. 0.2 and 0.3 is going to give me 0.5. Okay? Or you can say 50%. Good job, Miss Blyther. Okay, good job. Letter D. We're on letter D now. What is the probability that Jenna buys at least 3 bananas? At least 3 bananas. At least. If she buys at least 3 bananas, okay? So if you buy at least 3, that's 0.2. Okay, at least 3. You can't say at least 3, but you only have 1 banana, or you only have 2. He said at least 3, so that's 3. Okay. Now the question you have to ask yourself: if she bought 4 bananas, is that still at least 3? Or if she bought 5 bananas, will there still be at least 3 bananas? Okay? So it's kind of tricky when they use the words at least. Okay? So that's kind of tricky. Okay? It's kind of tricky. If you look at choice E, letter E, it says, what is the probability Jenna does not buy exactly 3 bananas? Does not exactly buy 3 bananas. Then you would look at the 0, the 1, and the 2. Because it said does not buy exactly 3. If I bought that 0, that's only 1, that's only 2. Okay? So you would add up all 3 of these here and get 0.3. Okay? So if we had to go back up to letter D, what is the probability that Jenna buys at least 3 bananas? Then you have to add up those for 3, 4, and 5, which would give you 0.7. Okay? So for letter D, you would get 0.7 or 70%. For letter E, you would get 0.3 or you would get 30%. Okay? It is all about the wordplay. That's it. It's all about the wordplay. I know you guys can pretty much read and understand the chart very good or the table, but it's all about the wordplay. That's it. That is it. It's just all about the wordplay. All right, so right quick, because we only have 1 minute left, okay? Please, ladies and gentlemen, listen up. Listen up, listen up. Please understand when I say this. I really appreciate all of the engagement. You guys giving me answers in the comment section. But you have to send me copies or pictures of your answers from your exit tickets, the homework, or whatever it is I ask you to send to me, okay? That is a major part of your grade. Okay? That is a major part of your grade. A lot of you are doing the work now with me on live. You are giving me answers in the comment section. They are correct answers. It appears that you know what you are doing. But I need you to submit to me your your exit tickets and things of that nature. Okay? If you are not submitting your exit tickets or doing the homework, you are not getting all of your grades. Okay? You are not getting all of your grades. The homework is going to be for you guys to complete page 7 and page 8. Page 8, it says the exit ticket. Okay? If you forget, like I've been saying, if you forget what you're supposed to be doing, please check either myself or Miss Felice's page. Okay? Miss Felice makes good pictures or notes to help you guys out and to remind you what is going on. All right? Please. Grades go in this Friday. Okay? Grades will be put up this Friday for term 3. Okay? For term 3. Please do not forget. Okay? Do not forget. All right. Once again, thank you guys for joining today. Thank you for your participation. I hope you have a safe, blessed, and happy day. Don't forget to tune into your other lives today and tomorrow. I know you guys have Miss Smith at 1 o'clock today. All right. Please. Also, if you don't have the package, the school will be open this Friday and Monday. Go by and pick up the package, okay? They're also handing out the new package that we'll be starting on next week. So please, go by the school Friday and Monday from 10 o'clock a.m. to 2 p.m. Will we get report cards sent to us? I'm not quite sure about that, Mr. King, but you will be able to check Aspen and your grades will be updated, okay? I'm not quite sure they should be updated. I just know that teachers have to put them in sometimes Friday and next week, okay? But you can always check out Miss Strickland or Miss McDuffie's page. They will be giving you guys more information than I am, okay? They will give you more concrete information that are dates that you need to know about, okay? Mr. Carter, you will have to contact Miss Strickland, Mr. Kennedy, Miss McDuffie about getting a computer, sir. That is out of my control. That's out of my control. Any more questions? What do you do with the package? You have to go drop them off at the school, Miss Wallace. You can take that back. You can take it to the school on Friday when you go pick up the new package. There will be someone there. If you see the comment, someone said grade level is live at 12:30. So if you tune into the grade level page. There will be Miss Duffy and Mr. Kennedy going live at 12:30 today. They will give you guys all the information you need to know, okay? All of it, okay? Please, please, please tune in with Miss McDuffie and Mr. Kennedy at 12:30 today. Are there any more questions? Miss Wallace, you turn the package in to the school when you complete it. Okay? You can go by the school Friday and Monday from 10 a.m. to 2 p.m. Drop the package off that we're working on and pick up the new one. All right, Samuel, man, enjoy your day. Are there any more questions? Yes, when you go by the school, Darian, and drop out this package, they will give you the one for week 6 and week 7. All right, y'all have a blessed, safe, and productive day. I will see you guys at 12:30 when you join in with Miss McDuffie and Mr. Kennedy on the Charles Hart 2025 page. Okay? Enjoy the rest of your day. Do some math and have fun.